Welcome my dear students to today's video. How are you all? Hope you are fine at home during these days. So today we are going to study about the second part of our chapter 2, that is about the bases. So let's go to the video. So in this video we will study about bases. So in our previous video we have learned that what is an acid and what are the properties of an acid, is it? So those who are not seen the video, please go to the link and you can see that. Now in the case of acids, we have studied that acids are generally sour in taste, is it? Then what about bases? We know that bases are bitter in taste. Bases are bitter in taste. So we can say that it is a characteristic property of a base, that is they are bitter in taste. Then is there any other properties? Yes, we have so many physical properties for the case of a base. Before going to it, let us see what is the classification of base. We can classify bases into two main categories. They are strong base and weak base. Okay? Strong base and weak base. Strong base and weak base. What is meant by a strong base? Strong base means the base which completely dissociate in water to give OH minus ions. So we can say that complete dissociation. Complete dissociation stands for the strong base, and if it is partial, only partial dissociation is there, then we call it as a weak base. Okay, so if a base completely dissociate in water to give OH minus ions, then we call it as a strong base, and if partially decompose or partially dissociate in water to give the OH minus ions, then we call it as a weak base. Clear? Now, is all bases are soluble in water? No. Depends on the solubility. We can divide a base into two categories. They are soluble bases and non-soluble bases. Then what about these soluble bases? Is they have any other name? Yes. These soluble bases are commonly known as alkalis. This is the name given for soluble bases. What? Alkalis. So what is meant by an alkali? Alkali means the bases which are soluble in water are called alkalis. Okay? Did all the bases are soluble? No. All the bases are not soluble in water. So we can make a general conclusion for this based on the solubility that all bases are not alkalis, but all alkalis are bases. Okay? I hope it is clear to all. Yes. Now let's move to the properties of bases. We have two properties for the bases. The first one is physical property and the next one is chemical property. Okay? Physical property and chemical property. Let us see the physical property first. Now the physical properties. There are 5 physical properties for bases. Let's see what are those physical properties. First physical property is, as we know, all bases are bitter in taste. Bitter in taste. Okay. Second physical property is that they feel slippery or soapy feeling on touch. Soapy feeling on touch. We feel soapy feeling or slippery feeling while we carrying the bases. Now the third one is very important. We have to remember it very carefully because we may have a confusion. In the case of acids, already I have told you what is the shortcut for it. In the case of bases, we can say that it is BRB. Okay? You know what is the shortcut of BRB? BRB stands for bases turns red litmus blue. And do you remember that what we have studied in the case of acid? We have learned ABR in the case of acids. That means acids turn blue litmus red. Here we have BRB. That means bases turn red litmus blue. Now the fourth physical property of bases are being electrolytes. Bases are commonly electrolytes. Being electrolytes, they conduct electricity very easily because they have ions. So they are good conductors of electricity. Conduct electricity very easily. Okay. Now we have the fifth one. Bases, some bases, or we can say generally, are corrosive in nature. Corrosive, you know what is meant by corrosive? Corrosive means if it falls on our body or anywhere in our clothes or books, it can cause harm. Okay, that is meant by corrosiveness. So these are the 5 physical properties of bases: bitter in taste, soapy feeling on touch, BRB, don't forget it, bases turn red litmus blue. Then they are being the electrolytes, they are good in conduction of electricity, and they are corrosive in nature. Clear? So these are the 5 physical properties. Now let's move to the chemical properties. We have to study 3 chemical properties of bases as very important. Okay, they are, the first one, reaction of bases with metals. This is very important because the examples of this reaction can be asked for the examination, board examination, especially for completing the reaction or balancing the reaction. So it is very important. As we have seen in the case of acids, acids when react with metals, it will give out or evolve hydrogen gas. The same reaction here also. Whenever base react with metals, it will give a metal salt and hydrogen gas. So we can write a general equation here as base plus metal gives a metal salt plus hydrogen gas will evolve. A better example we can write NaOH. We know that it is sodium hydroxide, and zinc metal, it will give a compound called, you have to remember the name of this compound, Na2ZnO2 plus H2. What is this Na2ZnO2 called? This is called sodium zincate. Sodium zincate is the name of this compound. Is it clear? Now, the next example which we can write, that is sodium hydroxide itself plus tin. This is called tin. So what we will get? We will get Na2 SnO2 plus H2. So this is called a sodium stannate. Okay, sodium stannate is the compound which is obtained here. Sodium stannate. So these are the 2 examples of first chemical property, that is reaction with the metals. Now we have the second chemical property. It is very easy, which we have already learned, that is reaction with acids. What we have learned in the case of acids, that is reaction with the bases, but in the case of bases, it is reaction with acids. And we have named one another name for it, that is neutralization reaction. Neutralization reaction. Why do we call it as a neutralization reaction? Because in this reaction, the salt obtained is neither acidic nor basic. So we call it as a neutralization reaction. Let's write a general equation for it as base plus acid gives salt plus water. This is a general equation which we can write for the reaction with acids. Let's write an example. The example is, shall I erase? Okay. The example for this as let's take the common example, formation of sodium chloride, NaOH plus HCl acid. We will get NaCl plus H2O water. The common example. Is it clear? Now we have the third one. The third chemical property is, what is the third chemical property? The third chemical property is reaction with non-metallic oxide. Reaction with non-metallic oxide. Okay? Reaction with non-metallic oxides. In the case of acids, we have seen that it was reaction with metallic oxides, and we have studied that metallic oxides are basic in nature. That's why they react with acids. But here, non-metallic oxides are acidic in nature, so they will react with base to form a metal salt and water. Yes, so we can write it like this, that is base plus non-metallic oxide gives what? Metal salt plus water. We will get a metal salt and water will form. Okay. Now we will write an example for this one. The example is that NaOH, sodium hydroxide, plus CO2, carbon dioxide, is a common example of a non-metallic oxide. This will give us what? Na2CO3, sodium carbonate, plus H2O to NaOH. Okay, H2O. Is it clear to all? So this is about the three chemical properties, three important chemical properties of bases. Let me repeat again. There are three chemical properties are there. The first chemical property is reaction of bases with metals. Second one is reaction of bases with acids. And third one is reaction of bases with a non-metallic oxide. So is it clear to all? Okay. If it is clear, please do share this video to your friends. Thank you.